Now we will explore radical expressions and equations. First of all, I'd like to look at a few definitions, or mention a few definitions, and then the rules that will be needed to simplify radical expressions and solve radical equations, and that's what this chapter is going to be mainly about, this topic. So the very first thing I want to talk about is what the heck is a radical expression? A radical expression is just any expression that contains a radical. The radical is this symbol. And we have, it could be a square root, it could be a cubed root, fourth root, and so forth. A radical equation is just any equation that contains a radical expression. And so with equations, we'll solve for the variable. With expressions, we're going to simplify, and just as we did with other topics. So another thing that I do want to define that people will mix up once in a while is, what is a square root? A square root is a number, when squared, is equal to the original number. So if I asked you, what are all the square roots of 16? The answer is not just 4, it's -4 and 4. But when I actually denote it with a symbol, with the root symbol, the radical symbol, square root of 16, then I'm actually asking you for the positive root, and that's it. So the positive square root of 16 is 4. So when we ask you the square root of 16 with the root symbol, the radical symbol, it's going to equal 4. So these are just a few definitions that will help us as we go through. The next thing then we're going to look at the rules that are going to be needed as we go through this, and we'll be hitting on these in the videos when we attack the problems. The very first rule is, the main thing to know on this stuff is going to be the radical form to rational exponent form. We're going to use that, we're going to flip-flop back and forth. They're actually equivalent. So it'll help us to solve problems sometimes, and we're even just going to explore simplifying just rational expressions with rational exponents. So when I say fractional exponents, when I say rational, it means just the exponents are fractions. They follow the same rules as if we had integer exponents that we've learned in the past. So basically, to know this, when I have something in radical form, I can translate back and forth to help me solve something. If I realize this is the index, we call this the index. This right here we call the radicand. This right here we call the power. And this is just the radical sign. And you can go back and forth and just know that if you write it in rational exponent form, they say the same thing. This is actually just going to be power over index. And so if you can look at your radicand, it's just going to be your base in your rational exponent form, and then it's just going to always be power over index. One thing you can try with your calculator is, the square root of 4 should be 2, so try 4 to the 1/2 power, power over index, and you should get 2. And so that is the one thing to note. Another thing to note is when we do square roots, we do not write the 2 because it's assumed. If it was a 1, because the indexes will always be integers, we wouldn't start with 1. The reason being, if there's a 1, if it's power over index, the index is a 1, it's just going to be, there's no need for the radical sign. It's just going to be a whole number exponent. So this is assumed as a 2, so remember that. You can even add the 2 in the problems. So with square roots, we do not for the index. All right, so that's one thing to know as you're doing the problems. You can add the 2s if it helps you when you're switching back and forth forms. The next thing is the exponent rules. I'm not going to list them all, but we're going to do the same exponent rules that we use with integer exponents, but we're going to deal with fractional exponents. So we'll deal with the product rule. So 2 like bases, when you're multiplying, you add your exponents. We're going to do the power to power rule. You multiply your exponents. Negative exponent rule, you send up and down any negative exponent, and the exponent on that base becomes positive, and that base gets sent. And we're going to deal with the 0 exponent rule. It's all going to be the same rules. The quotient rule, top exponent minus bottom exponent. Same rules. We'll use those rules as we attack the problems. You can refer to earlier notes, or you can look in the textbook we're using now. You can look in the very beginning of chapter 6. Actually has all of them spelled out. The product rule for radicals, we have basically they fall from the exponent rules, but we're writing in radical form. So if you're multiplying two radicals with the same index, then you can multiply them together underneath, as long as n is greater than or equal to 2 and n is an integer. The index will always be an integer. It's going to be greater or equal to 2 because it doesn't make sense to start with 1. And so you can, that's something that we're going to use to help us simplify or multiply these things and simplify. Quotient rule, if I ever have a fraction within the radical, with the index like that, I can break it up into taking the root of the top and the root of the bottom, as long as the denominator is not 0. So I have to say b is not equal to 0, otherwise it's an undefined term, and n also has to be greater than or equal to 2. The one tricky one that trips people up a lot is this rule. If you ever have the same indexes, the same power, and they're even, it's n is greater than or equal to 2, but it's an even number, like say a 4 and a 4, if this is a variable and you're trying to simplify this down, you'd actually really have to write an absolute value around it, because it could be negative inside of here as a base, but when you square it or bring it to an even power, it becomes positive, so that forces the absolute value. So the real correct answer, you see, if you're trying textbook examples, you'll end up writing, you'd have to write the absolute value. Now, when I test you, I'm going to let you know let you know in the problem that we can assume that the variables are all positive numbers, so you don't have to write that. But just know that when you're working on your homeworks and stuff, you'll have to watch for that. I won't test you on that thing in particular, though. And then also, if they're odd, it's okay to be negative. You can have a negative output then, because an odd number multiplied together. So if this was like a 3 and a 3, you could actually have, and we'll do problems like that, it'll just be the base. It could be negative as well, because it's an odd number. And those are all the rules that'll help us solve this chapter. And so we'll hit them as we do specific problems.